good day everyone, you're welcome to Master Lectures. Now let us take a look at this possible chemistry question that has been asked over the years in JAM. Now sometimes they repeat the same questions, other times they just change the values and the gas involved, but it is of the same pattern. Now this question that you are seeing on the board, 200 centimeter cube of oxygen gas diffused through a porous plug in 50 seconds. How long will 80 centimeter cube of methane take to diffuse through the same plug under the same condition? Now this question you are looking at, whenever you see a question, first thing you should tell yourself is which topic is this question coming out from. If you can be able to realize the topic in which the question is coming out from, then you'll be able to know how to go about your way in trying to calculate and get your answer. But guess what? This question is very easy because I'm going to be showing you the secret right now. Now, first thing first, this question is coming out from the law of one of the gas laws known as Graham's law of diffusion. This question is simply coming out from Graham's law of diffusion. Now, Graham's law of diffusion is one aspect of gas laws that some students find very difficult, but it is actually very easy. It's actually very easy, and bulk of questions under gas laws, they are usually from Graham's law. All right. So although we have other aspects of gas laws that we are going to be looking at subsequently in other video lessons. All right. So but first today let's concentrate more on Graham's law of diffusion. Graham's law of diffusion. Now in Graham's law of diffusion, it states that the rate of diffusion or effusion of a gas is inversely proportional to the square root of its density. All right. It simply means that if a gas, the rate at which a gas will diffuse, whether fast or slow, it is inversely proportional towards the square root of its density. So what does inversely proportional imply? It implies that if you have a higher rate, all right, for the rate of a gas to be high, the density or the molecular mass of that gas needs to be low. Are you with me? For the rate of a gas to be high, the density or the molecular mass, all right, the weight of the gas needs to be low. And if the density of the gas is high, what will happen to the rate? The rate we have to what? Reduce. Okay? So if the density of the molecular mass of the gas is high, the rate we have to what? Decrease. Now, if you look at this question, 200 centimeter cube of oxygen diffused through a porous plug. Now, we need to do something here. We need to find the molecular mass for oxygen and find our molecular mass for methane. All right. Now, oxygen is a diatomic molecule. Oxygen is a diatomic molecule, O2. Now, O is 16. All right. O is equal to what? 16. So therefore, to now get our O2, we'll now say 16 times 2, which is what? 32. So the molecular mass, all right, of oxygen, which you can also refer to as the weight, all right, the heaviness of oxygen is what? 32. Now let's look for that of methane. Methane is CH4. Carbon is 12 plus hydrogen is 1. But this 4 is affecting the 4 is only affecting hydrogen, not carbon. So you now say what? Times 4. So 1 times 4. So when you do that, 1 times 4 is 4 plus 12, you get what? 16. So now what? Between 32 and 16, which one is higher? Who is higher? Is 32, right? So that's to tell you that oxygen has more weight. It has more dense. It is more dense. Oxygen is more dense than methane. So now, because oxygen is more dense than methane, the rate of diffusion in oxygen will be slower compared to methane. The rate, because oxygen has a high molecular mass than methane, 32 and 16, 32 is bigger, 32 is bigger. So because it has a high molecular mass than methane, so you will now say oxygen is denser than methane. So now remember, for the rate of diffusion to be high, the density needs to be low. Alright, and if the density is high, the rate of diffusion will be what? Will be low. So it simply means that oxygen being 32, methane being 16. So it means that oxygen will diffuse at a slower rate and it will take more time, while hydrogen with methane will diffuse at a faster rate and it will take less time. So now look at it. Looking at this now, you have it 200 centimeter cube of oxygen diffused through a porous plug in 50 seconds. How long will it take what? How long will 80 centimeter cube of methane take to diffuse through the same porous plug under the same condition? Now in this question, there is actually a long method to solving this question, but we're just going to go with what is easy, alright, in mass flow lectures. Now there's this secret formula that you just need to memorize. V1, it is V1 over T1 equal to T2 over V2, which is times, there's times here, then equal to root M2 over M1. Now with this formula you can solve questions of this pattern where you'll be given two volume, you'll be given one time, and they'll tell you to find the other time, and definitely you have your molecular mass. So just use this formula, very straight and easy. Now what's the V1? The first volume is what? 200 centimeter cube. So 200 over, what's our T1? The first one, 50 seconds, 50 times, what's our T2? That's what we are looking for. How long speaks of time. How long will it take? So we have X over, what's our V2? Our V2 is 80 centimeter cube. Right, so we have 80 equal to square root of what's our M2, which is the second molecular mass of the second gas. That's M2. So the second gas here is methane. The molecular mass of the second gas, M2, is 16 over M1, molecular mass of the first gas, which is oxygen. All right, and oxygen is what? 32. So you have 32. Then from here, 200 times x is 200x all over 50 times 80. So quickly, let's go through it. 50 times 80. So in 50 times 80, we have 4,000. That's 4,000 equals, then square root of 16. Square root of 16 will be, square root of 16 will be 4 over, then square root of 32. Square root of 32 will be 5.65. And then at this point we are going to cross multiply. So by the time we cross multiply, we have 200 times x will give us 200x times 5.65 equals 4 times 4,000. So 200x, or just forget about the x, say 200 times 5.65, that is 1130. Then just add the x equal to 4 times 4,000, that is 16,000. So at this point we are going to divide both sides by the coefficient of x, the number carrying the alphabet x. So when we do that, we have 1130x over 1130 is equal to 16000 over 1130. So this cancels out this. Therefore x, alright, which is our time that we are looking for, will now be 16,000 divided by 1130, and we'll get 14.15 seconds. Alright, when we go through the option, we just have 40 seconds, so automatically, alright, no need to do any form of approximation, which is still the same thing as 14 seconds. So that becomes the answer. So the answer becomes option C.